needed to set up the lighting and everything so I could make a recording of this. And in doing so, I accidentally pulled on the plug for the computer, and the computer shut down, and I had to reboot it. I was managed to recover a lot of the windows I had open on the browser, and a majority of this presentation that I was putting together, I still have, a save, so we can still go through it. But I wanted to go over a couple of things with you about meters. I know I sent you that assignment, but a lot of you guys didn't really, well, Christian was the only one that did it, but you guys really didn't think out of the box. I mean, yeah, we do a lot of voltage and ohms testing for a majority of everything we do. When we use testing, we use those two meters like religiously. But sometimes we have to do an amperage test. Sometimes we have to do a wattage test. Sometimes we have to do a temperature test. Sometimes we have to do other tests. And there's a lot of different meters out there. Sometimes one meter may have all these different settings on them, but sometimes that's not the best meter. Because even though it does all these things, to make it fit, like all the other meters, like a certain size, you lose in quality. And you go, oh, I got a Fluke meter and I got this and that. Yeah, Fluke is a good meter. But you don't need a $500 meter to fix appliances. Or if you're doing air conditioning, you don't need to do air conditioning. So I wanted to talk a little bit about the different types of meters. Real quick, let's make a list of the things that you want to have, or you think that you should have if you're going to get a meter. You're going to do an ohm meter, right? What else?
Right.
What?
Yeah, I like for me with my Fluke, mine has volts, amps, because it has the clip-on amp meter, and then I have an analog thermometer that I use.
Okay, but let's go volts, AC, and DC, right?
Yeah, it does.
And a meter. And you want what they call a clamp on ammeter.
Yep.
A regular ammeter, like the real small ones or cheap ones, those you like break a circuit in half and the meter goes in line with it and in series with it basically. And that's not what we need. We need to be able to clamp around a wire and make a test. And when you're doing that type of test, you don't clamp around all the wires. Like you can't check around a regular power cord. You have to take one of the lines, either the line or the neutral, the one coming in or the one going out. You cannot test both because they cancel out the reading that the ammeter does. What else? Watt meters, right?
Yeah.
And you said a temperature tester?
Well, so I have two meters. One's from Klein. It has a thermostat, the thermometer on it. But I also have an analog thermometer that I like to use.
Well, real quick, let's look at a temperature tester. Give me some examples of things you guys would check temperature of to see, let me see if this is working at the right temperature.
An oven or a range.
Okay, oven.
Dryer.
A dryer.
A dryer.
Okay.
A refrigerator.
A refrigerator.
Specifically like the ice maker, the freezer, the refrigerator cabinet itself.
What
Or
else?
even check the temperature of the gas that's in the system.
Well, you don't check temperature of gas. What about the water in a dishwasher? What about an air conditioner? I know we don't do central air, but we do wall and window units, so that's... Now, does one meter test all of them accurately?
Not necessarily. It'll slack in some areas than others usually.
Well, what type of temperature probe would you use?
Well, the one on my Klein meter actually plugs into the meter lead, and you can line it in there. It's got like a thermal cover all the way all the way up until the tip, or you could use it on like an oven or something.
Mm-hmm.
But I don't know how accurate it is. I haven't set it up in a while. But I would just calibrate it with ice water every time before I used it.
Okay, so if we had a temperature probe or a temperature tester, it looked like something like this.
Not the probe. It's just got a little wire lead. It doesn't actually have like a probe to it.
Well, this is it's got a wire on the end of it instead of an actual probe, right? Like this one here we wouldn't use. This is more like a thermocouple tester. But this one is a pocket thermometer here. And a pocket thermometer is pretty good. But where would you use that?
For the pocket thermometer?
Yeah.
Well, I used to use it more when air conditioning because I could use it for the air vents to test the pressure of like the pressurized air coming through the system.
The pressurized, so
I'm trying to think the terminology for it.
You check the airflow coming out of a dryer?
Yeah, you use it for the airflow coming out of a dryer, the return air on an air conditioner.
I think it's more accurate in liquids, like water for the refrigerator, if you're trying to get a measurement.
Okay, so yeah, you can do it in water, like that would be okay, like a dishwasher, like you want to put it under water as it's coming out. You can put it inside a refrigerator. The problem is, as soon as you open the door, you let warm air in. So the accuracy of a temperature of a refrigerator, the accuracy of a temperature of a dryer is not going to I'm sorry, not a dryer, but an oven is not going to be that good because you have to open the door to get a reading. So let me ask a question about these type of meters here. Give me a second. I just took a screenshot. I'm going to bring it into the presentation here. What about these meters?
Those little infrared thermometers are pretty good, but they usually only test like the surface of something. So if you were trying to measure the inside of a range, you would only measure the temperature of the door itself.
It fluctuates a lot depending on what surface area you're in at that particular moment.
Yeah, so it works good now because you see all the places, including schools, going to start using that when you guys come into class to make sure that, you don't have a temperature. But using them for appliances is not that great because, it's good for measuring airflow, but it's not that great for measuring like actual temperature in a static location, like a refrigerator or a dryer or oven. As the air's flowing, it's not going to be that accurate. It'll be close, but sometimes accuracy matters, sometimes it don't. Sometimes you have to be right on the money when you're making those tests. So I wanted you guys just to see that there's many different types of meters out there, and we haven't gone over. We can check gas pressure, refrigeration gauges is an actual meter. We have all types of meters out there. So when I asked you guys to look up a meter and tell me what meter you would get and why, only two of you had any sort of response, and you're always thinking about the multimeter, where the multimeter does ohms, volts, watts. There's many different kinds out there. So the one thing about our industry is you don't have to be that accurate with the tests that you make on appliances. If you're doing electronics, a half a volt makes a big difference whether something operates properly. You're asking me just now, Pedro, about a low wattage bulb and it's not working inside the refrigerator. Well, if it's a 110 volt bulb and it's 15 watts, I don't care. If it's plugged in a refrigerator, it's gonna work at it's going to work, but it's just not going to be that bright. 120 volts is 120 volts. I don't care if it's a socket in a refrigerator or if it's a socket in a wall lamp. It's still, if it's 15 amps, I'm sorry, 15 watts at 120 volts, it's going to be 15 watts in a refrigerator. So the appliance itself should make a difference. So if the bulb is not working, it has to be something else. Either connection of the bulb is not good within the socket, there's a corrosion on the point where the bulb meets the socket. Usually it's copper and it doesn't corrode too much, but it happens. So meters are important, that we have the right meter. And let's talk a little bit about digital, analog, a meter or a multimeter. Here we have several different analog meters, and some of them have more or less scales on them. You know, sometimes when you guys go to buy a meter, you got 100 scales or 50 scales, like this one meter here's got so many scales, and so does this one here. You need to look at the meter. You need to look at the meter and know what you want to test before you buy your meter. And that's why I gave you this assignment, because yeah, a lot of meters have all these fittings and all these settings and all these crazy things on them, but why get it if you're not going to use them? You know, give me a second. I'm trying to find where you guys are in my Google Meet page. I lost it. So, anyways, it's still there. So we have all these different meters here. We have all these digital meters, and there's a clamp-on ammeter down here in the middle, and we have all these analog meters. I personally like analog meters. A lot of the newer guys, and you know, I didn't have digital meters when I started, and a lot of people say, well, that's why you like analog, because you didn't have digital, and if you had digital then you would love digital. I like digital, but analogs, to me, the needle moves, and a lot of people don't like to do that math. Oh, if it's on this, if it's on the 2K scale and it's on this reading, it's this many ohms or it's that many ohms, I have to do the math. Digital meter shows you a number, and that's the answer. I like analog meters because the needle doesn't jump around. The needle goes to one point and it stays there. Digital meters, the more sensitive they are, or the more things they do, the more when you're making a test, if you just apply just a hair bit more pressure on those meter leads, you're going to get a crazy reading. You're not going to get just a single number. The numbers are going to be jumping all around, and you still have to guess at what the reading is. Now, over a period of time, and you get to use it, I don't care if it jumps 240, 250, 240, 250. Okay, I got 245. But I don't like that sensitivity of that meter. I like it just to be one point, and I look at it and I say, that's what I got. But analog meters aren't that great either, because if they don't have the right number of batteries inside of them, they can't do everything we want it to do. I always tell people when they come into class and they say, oh, check out this fluke meter I got. I paid $499 for this meter. I said, does it test, does it test, give me a second here. Does it test diodes and microwaves? And it says, yeah, it's got a diode symbol on here, so it should do it. Yeah, but a microwave diode is about 50,000 ohms, and it's only one way. Most of these meters don't have enough battery power to make that needle move through that higher resistance. So if you're making a test with one of these analog meters, even though they have a diode scale or the digital meter, most of these meters need more than 9 volts to read through a diode. And if you go on YouTube, hold on one second, let me find it. You go on YouTube and they show you how to add a battery to your meter. Let me just type it, to test a diode. Now give me a second, I cannot find my Google class. I don't even know if you guys are still there.
Here.
Okay.
I'm here.
You guys are still there. I had it. I had it open, but I cannot find the window now. It's almost like it's closed. So okay, but anyways, all these meters are good. You don't need to spend thousands of dollars on a meter. How to test a diode? Let's see something here. This guy's going to show you how to test a diode with a multimeter. So just take a look at this for a second.
Test a diode. It's a really simple process. Most multimeters have a setting for testing diodes. You'll see the diode symbol right there on the...
Now here's a problem. Look at those diodes. We don't deal with those. We don't repair computer boards. We're testing a diode from a microwave. And these little diode symbols are not for testing microwaves. So let's take a look at this video for a second.
Hi guys. Long time ago I made a video about how to test a microwave oven diode. I showed how to test a good one, but it was not so clear to everybody, so I decided to repeat the video. But first, let's understand a rule. Microwave oven, from the TV, from the stereo, from the refrigerator, washing machine, or computers, is the electrical device that most people kill around the world. Yes, it's very dangerous. So, first rule of electricity is electricity kills. Keep it on mind and don't be fooled if you don't understand how a microwave oven works. Don't try to fix it. Bring it to service. Back to the diode. Diodes are electronic components that will let the electricity to flow in one direction and will block the electronics flow in the positive direction.
So real quick, and I ask you guys a lot when you look at this symbol, I said which way does it flow? Left to right in this picture or right to left? And the answer is right to left. The arrow's pointing to a wall so the current cannot flow through there. So what a diode's doing is converting AC to DC voltage. Well, if you look at this diode in this picture here, you see this silver line. Look at the silver line on here. That silver line is representing the wall. That means the current cannot flow left to right in this middle picture here, and then it flows from right to left. So the same thing goes here. If you look at this diode here, one side of the diode plugs onto your capacitor, the other side goes to ground. The current doesn't go towards ground, it goes from ground up. That's the current flow on it. So that's how you read it.
Direction. It means this diode will conduce electricity in this direction, but in the positive direction it cannot pass. Why this kind of test? Because with the digital multimeter, the voltage is too low, and this kind of diodes, they require higher voltage for polarization. So we have to use a 9 volts battery. First, we have to make a measurement of the voltage, so we will know what are we dealing with. .15, 9 volts.
Now, he's just checking the voltage of that battery. But when he goes to check the diode, not only is he using that 9 volt, I don't know if he's going to say it, but he's using the battery of his meter as well, because when you do ohms, your meter uses the battery inside of it. When you're doing voltage, it doesn't use the battery. The battery on digital's for the display, but the voltage is what makes the meter get a reading. On ohms, it's the battery inside that makes the meter get a reading.
This is the rule. If the diode is in short circuit, I will get a measurement of the battery voltage 9 volts. If the diode is open, I will get 0 volts. If the diode is good, I will get a voltage drop in the diode, so the output voltage will be the battery voltage minus the voltage drop in the diode. That result is what I'm going to see in my multimeter. Nine volts.
Okay, so he's in DC volts when he's making this test. He's not in ohms. Some people use the ohm meter and use the battery to help push through that diode. But basically, he's checking the voltage of this battery through this diode. And he has it so that the ground port is going to the positive side of your meter, and the negative port here is going to the other side. So if he was to reverse this diode, he's not going to get any reading.
The diode is in short circuit.
So that's a good diode. It's going to read, if you see now, he's got 2 volts. So that's a good diode because the resistance inside is dropping the voltage.
9 volts minus the voltage drop in the diode. The diode is good. What about the open diode? I don't have anyone here. Okay, we can pretend we have it. Zero volts is an open circuit. Conclusion.
Alright, I know that was a long video for such a simple test, but a lot of guys don't know how to test a diode properly. And if you see, this is the reason why I didn't like the digital, because he had to have all these extra wires and a second battery besides his meter to test that diode, where some analogs have the battery inside to do the test all by itself. And a lot of meters you're going to hear, oh, this battery has true RMS. Okay, what the heck are they talking about? True RMS, and this I got from Fluke's website, is root mean squares, one of the tools that can measure alternating current or AC voltage. True RMS digital multimeters, average responding digital multimeter, clamp meter, oscilloscope. Only the first 2 tools are commonly used and both accurately measure standard sinusoidal waveforms. So it measures the waveforms. We don't do that. We may do that sometimes if we're trying to measure the frequency coming off an inverter board to a motor or a compressor. But even then, if it had some sort of frequency, we don't have the technical data that tells us the frequency we're supposed to be reading. So even if we had the capability of doing that, we cannot figure that out. We do testing on hertz sometimes for compressors, but this right here, you're going to see one that says true RMS. This is something someone who does electronics is going to deal with. This is not what you're going to need when you're working on a washer, dryer, refrigerator, or any of those basic appliances. You're not getting down to the very nitty-gritty of that sine wave and that voltage in order to test it. You just want to know, do I have voltage here? Do I not have voltage? Do I have ohms? Do I not have ohms? And having a good meter to make those tests is the only importance that you guys really need to be concerned with. Now we have all kinds of meter leads. And I took a screenshot because these are all different kits you can find on the internet. Amazon has a good one for 20 bucks. Again, you don't need all of these leads, and I'm just going to zoom in a little bit on it just to show you that the importance thing on some of these leads is maybe something like this. You have alligator clips and you have some real long pointy leads that are going to get you into some electronics plugs and testing components. All these other fancy probes and leads that they sell, and here's a big kit that Fluke uses, again, there's very rare times that you're going to use every single one of these leads in your lifetime. I'm saying all the years I use alligator clips, I use the long pointy ones, and I just use regular meter leads. Those are all you're really going to need. So don't go out and spend $50 on one of these huge kits of meter leads and you're not going to use half of them. You only need ones that are going to make specific tests that you like. Now, I do have a screen here of a meter. This meter is one that one of the students said this is the meter he would get. Okay, and I see it has a potential of a lot of different tests. We have DC voltage here. We have up to 1000 volts DC, and then if we look over here, we got AC 1000 volts. If you see right here, and I don't know if I can move, I can't move the screen, but right here you got DC 10 amps. You're not really going to do amperage. Here we have a little speaker in the middle on the right hand side. I can't keep the screen maximized, but on the right hand side you see a symbol like it looked like a little speaker. That's for testing ohms, but just a tones test. And then you got down here you got both diodes, and it looks like milliamperage and ultrafarads, but real low farads testing. DC amps on the bottom and DC milliamps on the bottom left you never use. And then I think here where this common is, don't hold me wrong, I think that's for testing capacitors and transistors and stuff. You'll never need them. That's not what we use. But I was reading it, and one of the things that I didn't like was the batteries that it said that it used. If you go to the product details here, this particular one in product details says it uses 2 AA batteries. Let me see where it is. I know it's on here somewhere. Here we go. Here's the technical data here. And right here it says power 2 AA batteries. Well, a AA battery is only 1.5 volts DC. Having 2 of them connected together means it only goes to 3 volts DC. Certain components in our appliances are 10,000, 50,000 ohms, and having a battery with that low a voltage might not be able to send power through these components, and the meter won't give you a reading. So even though the price is like $29, $30, well, guess what? It might not be able to test certain things from you, and now you're going to have to do one of those 9-volt battery things on the side to make that meter test the components you want to test. Now let's take a look here. I'm trying to find, I have it here. I got this. I'm going to send this link to you guys through email. It says bestreviews.com, best multimeters. And if you can see, it was updated as recently as July 2020. So it's only a week old. It's not an old article. And they did reviews on different types of meters and different types of tests. So I want you guys to take a minute and look at read this on your own. I'm not going to read it to you. The pros and cons of some of these meters and how you decide what meter is right for you. So go ahead and just read through this article, and I want to talk about that tomorrow, about the different things you can do. Now, one of the things you got to be careful is some of them have a voltage rating on them. And if we go back to that last meter we were just at, let me go back to that screen for one more second. I think it was this one. No, this one here. No, that's not the meter I was looking for. When we were looking at that other meter that did those tests, the maximum voltage rating of that meter is very important. Some of them are like 600, some are less. And you have to have the right voltage on your meter, because if your meter doesn't have the right voltage, it could jump voltage right through the face of the meter. I got electrocuted because a technical trainer had asked to borrow one of my analog meters, and it was in a leather case. And he had an oven with a microwave in it. And I said, oh yeah, I'll get you one of my meters. I said, well, what are you testing? He says, well, the transformer in the microwave, it has a high voltage output, but it only has a low voltage output of 3.4 volts. Only less than 4 volts AC is coming off these 2 leads. So I had put the meter on voltage, but it was on it was on 300 volts AC. So the scale was high. He was trying to read 3, and the meter was set to 300. The needle barely moved. So he's there showing the whole class. Well, before he connected this meter, I asked him, listen, I don't normally teach this to my class. We can do ohms test on these microwaves and check these components out. Checking high voltage like that is not that safe. So I said, are you going to disconnect the high voltage lead? He didn't really respond to me, but it was his product from his I'm not going to mention his name or the factory, from that manufacturer, and he's traveling around the state teaching technicians already working for companies that are authorized to work on their product. So who am I to, correct this guy of what he's teaching? So he set the meter down after he showed the class and listen, you guys really can't read it because the setting's too high on the meter, and he set the meter on top of the wall oven that was sitting on the middle of the floor. I reached over, I had one arm on the handle of the oven door, nowhere near the working components. The microwave was still running. All I did was reach over with my hand and attempt to rotate the dial to a scale where he could read that 3 volts. And at that moment, the voltage, the high voltage that was coming off that transformer and capacitor went through the face of the meter where the dial was and was electrocuting me. And as my hand was coming away from the meter, the students that were sitting in that class at the time, including technicians from factories, there was a lightning bolt that jumped through the air. Could have killed me. I got lucky and I was able to walk away from it. But again, if you don't have the right meter with the right rating, and you're not sure what you're doing, you can hurt yourself or hurt somebody else. So again, I'm not telling you this story because, someone made a mistake, but I am telling you a story so that you guys think about it when you make your choice for your meter, that you choose the right meter and you make sure that it's capable of doing some of the things you want to do. My favorite meter is right here. It's called the Simpson 260 meter, and I had a window open for that meter. Let me see if I can bring it up. I know I had it open here somewhere. Let me just close some of these other windows that I'm not using. There's Simpson 260 was the meter I grew up using. And it here, okay, here we go. This is the Simpson 260 meter. Man, this is old school meter. This meter here has all the ohms, the voltage, and everything that these other meters, both analog and digital, have. They have a scale here. Let me zoom in just a little more. They have a scale here for AC and DC voltage, DC plus, DC minus. They have up to 500 volts, 1,000 volt range here. I know the picture's a little bit blurry. 10,000 ohms of resistance. And they even have a place where you can plug in temperature probes, and you can actually test like the oven temperature, refrigerator temperature by sticking the probe in the oven, and a long wire would plug into this meter to give you a reading. This particular meter is one of my favorite meters. Brand new, they cost $300. But the nice thing about these meters is if you take care of them or keep them in a case, even if you mess them up a little bit, I recommend these meters because you can send them into a place that will recalibrate them and repair them and make them like new again. So these cheaper meters, $20, $30, you put the wrong voltage on the wrong setting, you blew the meter out. Now I wanted to show you here is that, look at a bunch of different meters here from eBay. Some people have them for $39.99 used. $40 used. That's what you're going to pay more than that for a fluke meter. But this particular meter uses a D battery and 2 C batteries. No, I think it has a 9 volt and 2 D batteries inside of it. So the 9 volt plus 2 D batteries, which are 1.5 volts each, will ramp that thing up to 12 volts DC, and that will test through a diode. And the accuracy of these meters, if you read about these meters are very, very accurate. These were used by electronics technicians back in the day and was considered the standard for the meters before all these digital meters and everything came out. So if you're thinking about different meters, I would think about getting one of these if you can find a good deal on eBay that the meter's working and that there's no problem with it before you purchase it. But even if you bought it for $20 and there was something wrong with it, for about 50 to 100 bucks, a lot of these places will recertify them for you and make sure that they work okay. So I really like the Simpson meter. It's one of my favorite ones. Just real quick, just to show you on eBay here, look at all these meters. Some of them are $181, $75, $30 used, $299 brand new, $380 brand new. So some of these are real expensive. You can see this one here has the nice case, and then sometimes a case cover over it. Here's a newer version of some of these Simpson meters. It's yellow and it's not these black ones. If I was to buy another meter now, I would want to get one of these here. So that's a personal preference. I like digital sometimes because digitals will check temperature, they'll check capacitors, where some of these analog meters don't have a capacitor test them on there. I use them for quick, easy tests. If I want a nice, accurate meter with a nice face and a good, accurate reading, one of these meters here are basically one of the best meters I could recommend for the price. So these meters here are very good, and if you're out there shopping for them and you buy one of these, I guarantee you, if you use it, it's going to be good. Now, if you look, some of them have series numbers, and the higher the numbers, I think the newer the meter is. So I'm not going to be 100% tell you that's the truth, but these meters are good meters, and there are things that you need to look into.
That is slightly different from the one I sent you, isn't it?
Well, I did show you yours. That was the one that I had posted on Amazon for 29 bucks. And it only had 2 AA batteries, even in the assignment.
Oh, okay. No, I got you. No, okay, that wasn't the one I was going to post that one. It was something looking like that, actually. But then I saw that it was really, really expensive, so I was like, maybe I should post a cheaper one. That was the one I was going to originally post. But then, the first thing didn't work, so I just changed it.
But for 30 bucks, you can get a brand new analog like the one that I showed you on Amazon. Or for about $10, $15 more, you can get a Simpson meter that, to me, still blows Fluke away. Now, I think Fluke is a good meter, don't get me wrong, and you'll get people that swear by a Fluke meter, but if I had the choice to pick up a Fluke or an analog meter, I'm going to pick up an analog meter. And now, I used to have a $10 Radio Shack one, a real tiny one. It was no bigger than your wallet, but it was a backup meter, very, very small, that if for some reason I blew the fuse on my meter, or I dropped my meter and it's not working, or the batteries died in my meter and I didn't check it before I left for my route that particular day, then I had this little tiny meter as a backup meter. But again, I don't want you guys to choose a meter based on, Mr. Z said this is the meter to get. I want you guys to try the different ones we have in class. And I'm going to tell you what, I'll go ahead and purchase one of these off of eBay, these Simpson meters, and give you the opportunity to test it alongside the other meters. Again, you don't need a $500 meter. It's going to take you a lot of service calls, or if you're getting paid by the hour, it's going to take you a week and a half of work to pay off that meter. But don't get the cheapest one just because it's a $15 meter and it lights up. You need to find a meter that has good quality, but not going to break the bank. That's what I recommend in meters. Do you guys have any questions about some of the stuff that I've talked about in meters? No? Are you all still asleep?
You were talking about the Fluke meters. Now, the Fluke meter I have had 1 amp meter and all of those, so it pretty much has most of what I would need, other than if I was testing the diode, I'd have to hook up a 9-volt battery and do all of that. So maybe in the meantime, for now, to save myself money to save up for one, I'd probably buy the alligator clips, where I could put a 9-volt in series with it. But just for the meantime, so I can get something a little bit more like the Simpson you showed us.
Yeah, again, don't go out there and invest a lot of money. The only thing is And it's the same thing with hand tools and power tools. You buy a screwdriver, a pair of pliers, and you find out halfway through a job those pliers are crap and they don't work right. Or you work twice as hard trying to take screws off because it's messed up. What you need is you need to have something that's going to be a good quality but not break the bank. So as you work in the industry, you find out what tools work best for you. All I'm trying to do is give you a variety of tools that are available to you to use, and you're going to have to make the decision on which one works right for you. Now, one thing that I like is I have a Klein digital meter. Oops, I spelled it wrong. I have a Klein digital meter. I can't even spell today, huh?
Klein.
Digital. I got a Klein digital meter. I forgot what the number was. Gerald, you got one of those, don't you?
I think Gerald has the one you
Yes, I do.
Yeah, this is the one I like. This is the MM400 if you're going to get a digital meter. I paid $35 for this meter. Take a look at some of the things this meter does.
See it covered now. In the middle, though, we've got the Syntec digital multimeter. This is probably the most widely owned multimeter.
Okay, so
You're looking at about $6.61 for this. Again, right there, the part number is 69401. I picked this up from Summit as well. It is also a direct ship Klein and Osteta company, so you'll get them.
yeah, I'm going to go forward a little
I will
bit
say
to show you
everything
the
that came
meter. The Klein meter I like.
It will be a lighter weight. You will need a number one Phillips. You don't technically have to use the number one Phillips, but let's be honest, that is going to be the best way to make this happen.
Now, before it goes any further, this Klein meter will do voltage, it'll do ohms, it'll do diodes. Let me see if I can go to the face of the meter here. It's a little hard to read there. Okay, right here, this is what I'll show you.
Connectors there. This is going to plug in here. We're not going to get.
So what he's showing you, and again, I'm fast forwarding through the video, I'll send you guys the link through the email, that's a temperature probe. So he can check the temperature of an oven, he can check the temperature of a refrigerator, he can check the temperature coming out of a dryer, he can even check the temperature of water just by plugging it into these two terminals here. But it also has Celsius, Fahrenheit. This here is microfarads. I'm sorry, not this one. This one here is microfarads. I don't know what this UA is. I'm going to be honest with you. I know this is milliamps. This is 10 amps. You're not going to use those too often. But the voltage, both AC and DC, and hertz. Hertz frequency is when you're testing I'm muting you, Ross, with all the noise you're making. That the hertz is when you're testing a refrigerator with a variable speed compressor, and the inverter board's on the compressor, but it has a separate main board like Electrolux. You need to check voltage from one board to the other to see if they're communicating. And one of the tests that you make is frequency. When the compressor's running at top speed, I think it's like 250 megahertz or something like that. So if you put this on hertz, you can measure the frequency coming from one board to the other, knowing that the main board is telling the inverter board how fast to run. And also if it's getting a communication. But the funny thing is that same two wires has both AC and DC voltage. And sometimes the prongs are so small, you need to use those real fine points that I use. Now again, I'm not going to run this whole video for you. I just wanted to show you this meter. This meter does carry a 9-volt battery inside of it. So again, it's not going to push through the diodes, but it will read a lot of the other things, volts, ohms. It has an ohm meter as well as a tone, capacitors, diodes. Don't worry about the diode. It won't work for you on a microwave diode. But those are the ones you're going to use the most. The volts, the hertz, the ohms, and the capacitance. And sometimes the temperature probe. So for $35, I purchased this meter, the MM400, like it says in the top of the dial. I can do temperature, I can do everything else. I don't really keep it in the case. I have my tool bag that it stays in. It wraps up nicely, and on the back, the meter leads plug right into it. And I spent a few bucks extra. So I think it was almost $10. That there's a clip-on magnetic adapter that holds the meter. So like when you're testing, it hangs on the back of the appliance. Let me look for it right now.
I think you can buy it on Amazon for like $15. I have one too.
And what I like about it is that way you don't have to hold the meter. Home Depot says it's $12. Here, Home Depot and Amazon's got it for $12.99. But this part here is the magnet, and this part here clips into the back of the meter, and it holds that meter to a magnetic surface or a metal surface that can be a magnet can stick to. And so your meter can hang from this while you're doing testing, so it frees your hands up not having to hold the meter while making the test. So, do I like digital meters? Yes. But if I had a choice, I'd take an analog meter over digital any day. I'd like to have both, because the analog meter doesn't do the hertz, it doesn't do the capacitor. But I like the accuracy of the analog meter. I can look at the scales and I don't need to do the math. I could tell you it's 2.5 volts, it's 25 volts, it's 250 volts. Just by looking at the scale, looking at the dial that I'm on, I already know what the voltage is. So again, it's just if you have practice with it and you've used it before, it is something that you'll get used to. So I'm gonna close this off now if you guys don't have any other questions, and I'm going to send you an email with the one web page that talked about the best meters of July 2020 and give you some different meters. And again, make your own opinion. Just listen to what they say are the pros and the cons and what they like about some of these meters and what they dislike to see which one will work for you. And then also I'm going to send you this video here on this Klein meter so you can see his reviews and go over the different things that this meter does. And like I said, Gerald and I forgot Chris had one of these meters as well. So we had some students that purchased this after I had it, after seeing what it can do. So do any of you guys have any questions?
Richard,
Yes, Joe.
I do. A UA is a milliamp.
Well, MA is milliamp. I don't know what the U is. It's almost like the microfarad, but microamps. That's almost a similar for Farad testing. I don't know what that is. I don't know what the UA is. We'll have to look at the spec sheet of the multimeter. You had a question, Ross?
No, I was just saying, I have a similar meter to that, but I bought the one that's I think it's the MM600 instead.
Mm-hmm.
And you have the little alligator clips that clip onto the end of the probes, and they've got some really nice long pointed probes rather than just the regular standard ones that I like.
Yeah, nowadays they're becoming more and more of a must because of the computer boards and the amount of wiring on them. Back in the day, we didn't have computers. We had mechanical timers and mechanical switches. Computers came out. All of us technicians looked at each other and said, "You gonna fix that?" Nobody wanted to work on it because they didn't know where to begin. But one thing that I have an advantage is I grew up with them, and now computer boards don't scare me. I look at them just like I look at a timer. So we need to know how to test them, and we need to have the right tools to test them. I always say having the right meter on the right setting is like a flashlight in a dark hallway. Without it, you're going to be bumping into walls and you're not going to know what you're doing. With a flashlight, you can see the end of the tunnel and you can find your way through. Having the right meter and knowing how to use it and the different scales that it gives you is like having a flashlight in the dark. You need to know all of these scales, so when you buy one of these meters, take the time to look at all the different scales and how do you use them. Don't wait till one day you have to test a capacitor and you never did the capacitor test on this, so you're like, I know it does it, I just never did it before. So when we come back to school, if you guys can afford to purchase a $30 or $50 meter like one of these, or or one of these Simpson meters, take the opportunity now while we're not in class and find yourself a decent meter so when we go back to school, you have it, and I can give you different things to test and show you the different scales and how will they work for you, because again, we're talking about troubleshooting, and I know we went over base electricity and diagrams, but meters are important, not just how to use them on a diagram, but what scales to use and what are the scales available to me to make all these tests.